For the Nano Hackathon, I built a project called Nano Connect, and what Nano Connect aims to do is provide a no-limits free way to connect to a Nano node currently supporting JavaScript or the browser. And what it's trying to solve is the problem of getting started working with Nano. Normally that involves running your own node, paying someone else that's running their Nano node, or having some sort of limited API. So the barriers are either a knowledge barrier, or a monetary barrier, or a limitations barrier. So what I'm aiming to do is making it easier to get started working with Nano by removing these barriers. And what that looks like is basically we have our client and server model, and the server is running the Nano node, and it's also running this Nano connection server, which is just a node server that has WebRT connections for the browser or for a terminal. And normally what this model will entail is having some sort of dedicated system with a static IP address that is up 100% of the time. And this qualification is relatively high for most people. So in my model, I'm assuming that the servers are not going to have 100% uptime. So to get around this, I'm imagining having multiple servers. So the problem with this is, how do we connect to this pool of servers? Like, how do we know how to connect to them? So we have what's called a discovery service, which all the clients connect to. And what this does is it allows the client to have one central point to find all the available nodes to actually connect to. Discovery service basically allows the clients to connect to the servers. And for this to work, I have what's called WebTorrent Tracker as the discovery service, which manages making the connections between the clients and the servers. What this looks like is the servers connect up to the WebTorrent Tracker. The client connects to the WebTorrent Tracker, gets the IP addresses from a server, and then does a direct connection from the client and the server. And once we have this direct connection, we can then disconnect from the WebTorrent Tracker. And now all your messages from the client are going directly over to the server. And what this aims to solve is the distinction between a distributed versus a central system. With multiple people all running nodes, we can scale up relatively big and have a relatively reliable system. Even though the individual won't be as reliable, there will be another node that will be able to manage that connection, versus a central model where we have one big computer making all these connections and making the transactions from the node server, which has a relatively high single point of reliability, but it requires a lot to actually keep that up. Distributed approach fits very well with Nano's design, because this is a low powered system, so we can have multiple people run the Nano node in the background without much problem. I'm imagining something in the order of like folding at home, where you basically, when you turn the computer on, you're running this small process in the background that doesn't have much effect on the actual system, but as a whole you create a very big network. And because everyone individually is taking on a little bit of the burden, we can allow this to become a free system, because no individual is paying for an increased load on their systems. And this idea of free is pretty big, because it allows for microtransactions to actually be viable for people who aren't running nodes, basically. And microtransactions can only happen if the transactions are completely free, because otherwise you'd be paying for it, or you'd be paying for something else down the line. And this idea of being free also makes maintaining the software a lot easier, because you don't have to worry about who's connected or how many connections they made, or basically you just accept that they've connected and you're good. And as for the web tracker service, it was there because it fit most of my needs, and it was a free service that I could actually attach myself to. So it made producing this relatively quick and easy. So we have a few examples we can look at. So I created a terminal application that connects to a Nano node in the background. And what it allows you to do is it allows you to run through the commands via the terminal. So a simple one would be block count. This sends an WebRTC message to a server, sends it back, and then spits out the JSON directly to the terminal without a single line of code. I also have a bunch of them. So another good one would be account balance. So I got an example address here, and we type in account balance, and see my current balance and my pending balance. And if you need or want to go into the code, I have an example here which runs a little web page, and it has the script on the left. So over here we're making the connection, and what the code looks like is basically we have a Nano client and it needs to connect, and you just have to wait until you've actually connected, and then from there you just have a bunch of functions on that Nano client to call. So to get the account balance, you just give your node address, and then you get a string message back, which you just have to parse. And then from there, you've got this JSON object, and you get the balance, just like we saw on the terminal application. Same for block count, same for history, and same for all the other commands I have available. So in the future, something that would be nice is to have a custom discovery server. And this would be nice because the BitTorrent tracker server isn't exactly designed to do the thing I'm trying to make it do. So in creating a custom one will allow for faster transactions. Other things would be really cool to have are the full breadth of commands from the RPC client. I specifically don't allow for certain commands because I didn't want to be on the hook for a bad block transaction for sending someone Nano, basically. And this is mostly because this is very much in like an alpha state. So I didn't want people to try to do something that might fail and cause harmful events, basically. And the last thing that would be make this actually really cool would be increasing the types of methods you can connect to it with. So currently it just uses WebRTC, but WebRTC is slow and is kind of like a hack. So what would be cool is you could just use a straight up TCP connection or a WebSocket, which are vastly faster, and you can quickly disconnect and reconnect if you need be. And that's basically it. But if you want to check out the GitHub repos, it'll be up here. Thank you for listening.